Hey, what's up, everybody? It is Mr. Grossarth, your favorite Mr. Grossarth. So let's get started. Today we're going to be beginning with Module 5, Lesson 1. So here's my chart. If you need a copy of the chart, it is there in the resources folder attached to this lesson. So let's get right into it. So what do I have here? I have a cube. So I want you to think about what's different between a cube than a square, for example. So take a moment to think about that. And really what the difference is that a cube has just more than just a surface. It now all of a sudden has something called depth to it. So it kind of pops out at you, right? So now it has a length and a width, and also it has a height, or this additional side that we haven't really talked about yet. Well, this is called volume. And we need to know volume because when you want to fill this cube with something, whether it be, let's say, a liquid, or if you want to fill a box with a bunch of these cubes, you'll need to know how big the box should be and how many cubes can fit in that box. So I have a really quick story for you. By the way, we're going to be exploring the volume by building with and counting with unit cubes. So my brother loves to garden. His name is Danny. Okay, he lives upstate, and every spring, right about now, he starts to prep his garden. So every year he needs to put a fence around his garden because where he lives there's, squirrels and chipmunks and rabbits and even deer, and I've seen them up there. So he needs a nice big old fence he wants to put around his garden. Now, we've talked about that before. Anything that goes around a garden, or anything, is called perimeter. And you just add up all the sides. Then, after he puts the fence, he needs to put fresh soil on his garden. So he needs to go to Home Depot, get some nice topsoil, and put it on his garden so plants can grow with some nice healthy soil. And so the amount of soil that he needs to put on top of his garden, we know by finding the area. So the amount that he's going to buy is going to be determined by the area of his garden. And we need to know the length of his garden, the width, and we multiply them. That's area. That's something that you've already learned as well and we've discussed. Now after that, he wants to plant flowers in his garden. And he's going to plant them in potters that look like this. They're cubes. And he needs to fill the cube pots with soil. So in order to know how much soil he's going to put in a pot, he needs to find the volume. So now he needs something else. He needs to find the length times the width times the height. And so let's take a look at this here, right here. I have what's called a rectangular prism. A prism is another fancy way of saying three-dimensional object. So here I have a three-dimensional object, or a rectangular prism, and I can tell what the length, width, and height is by counting. So first I'm going to find the length, and that's how far back it goes, and I'm going to count 1, 2 boxes. Then I'm going to find the width. That's how wide something is. 1, 2, 3. So the width is 3 cubes. The next thing I need to know is the height, and that's going to be 1, 2. So 2 cubes. So now I have the length, which is 2, the width, which is 3, and the height, which is 2. So now what I want to do, in order to find the volume of this, rather than sitting here and counting up all the boxes and trying to guess, which you could do, it's not the best way, I can find it by doing the length times the width times the height. So I'm going to do 2 times 3, which is 6. Then I'm going to do times 2, which is 12, which will give me a volume of 12 unit cubes, or cubic units. There's a lot of different ways we can say the unit, and we have to be very careful in how we say it too. We can't just say 12. It's 12 either cubic units or unit cubes. So let's take a look here. Now what's the difference between this one and this one is that we don't actually have the cubes here to count. Now we actually are given the measurements. So let's go take a look at how we do that. So we have 5 times 3 times 4. Okay, now again, since you know the commutative property of multiplication, it doesn't really matter the order that you multiply them in, just as long as the numbers are there and you're multiplying them. So we could do 5 times 3 times 4, we could do 4 times 3 times 5, we could do 3 times 5 times 4, and so on. So let's just go ahead and figure out the volume of this. Now, here our unit is in inches. So when our answer is not going to be in unit cubes, it's going to be in inches, but there's a way of saying that which we'll find out in just a moment. We have 3 times 5, which is 15. 15 times 4 is 60, but I can't just leave it 60. It's 60 inches cubed. Now, why do we put the 3 there? We put the 3 there because the little 3 lets us know that we're using volume as our measurement, and don't forget it. Okay, because if you forget that little 3, then I don't know what unit you're talking about. Okay, all right. So let's practice one together. And you, oops, there you go, that's off. So you might have seen this maybe in your problem set or in the homework, or I don't really know where, but we're gonna do this together now. So here I have my trusty marker. And let's go ahead and find the volume. So for this one, it's actually pretty simple. I don't really need to do much more than just count the boxes. So let me go ahead and do that. I have 1, 2, 3, 4, 5. Simple enough. So the volume to this is going to be 5 cubic units. Okay. The reason why this is simple, because there's no boxes that go back any further. It's just really just one. So, in other words, if there was another box here, it would make it just a slightly bit more complicated, but we don't have to worry about that until we get to the next one. The next one, you can see it has a length of 2. So why? How do I know? Because I counted. 1, 2. Now I need to find the width, which I'm going to do. 1, 2, 3. And now I need to know the height. The height is just count up now. 1, 2. So now, if I use my volume formula, it's going to be length times width times height. And I have, this is technically the length, but remember, it doesn't really matter what order you multiply them in. So it's going to be 2 times 3 times 2. 2 times 3 is 6. Times 2 is 12. And you have 12 cubic units. Now this one's a little tricky. Now I'll do this one with you, but I just want you to remind you not to be tricked, because you have to really pay attention to how something is drawn. Okay? So now here, if you take a look at the top layer, remember a layer is just a row of cubes. We call that a layer. We're going to get to that in another lesson. Okay? Just so you know, a layer is like a row. So that's a layer. And that's also a layer. So the top layer has 1, 2, and then don't be tricked, because you see this down here? You've got to count that one as well. So you got to not be tricked there, okay? So let's go ahead and count this. Because we can't really do length times width times height, because it's not even. Length times width times height works with like rectangular prisms or cubic prisms, or something that is even on all sides, or at least opposite sides are even. This one is a little bit funky, right? We need to figure this out by just kind of counting it. So we're going to do 1, 2, 3, 4, 5, and there's nothing behind this one, 6, 7, 8, 9. So the volume of this is 9 cubic units. Boys and girls, if you need more resources, attached is another YouTube video from Engage New York, which you can look at. I also attached a copy of my chart, and I will be online for this lesson Monday from 8:30 to 2:30 in the morning. Okay, so you feel free to message me on Google Classrooms. I will be available to answer your questions. And if you need more support, I'm here, okay? So anyway, check out the resources that I posted, and stay tuned for lesson 2.